Hello, welcome to our next set of college algebra notes. We're on Unit 1, Outcome 9, so only a couple more sections left in this unit. We're getting close to the end. We talked about functions last time in Outcome 8, and we showed how combine functions by adding, subtracting, multiplying, dividing. On this section, we are going to combine functions, but we're going to do it by a different method. We're going to do it by composition. So composition of functions is when you take two functions and you replace the x value one function with the other function. You're literally plugging a function into another function. Well, that's what this means. We write this with the notation f of g of x. So that's what this is. This is f of g of x. And what this means is that we're taking a function, f, and we're plugging in the g function. So this is called, again, it's called f of g of x, and we're going to plug the g function into the f function. So let's look at an example of this. I think this is one of those things where it makes a lot more sense to just show an example. So we're going to do f of g of x. So what this is telling us is we're going to take if we have f of x is the square root of x plus 3 and g is this guy, we're going to take the g function, this 2x minus 7, and we're going to plug it in for x in this f function. So when you f circle g, so f of g of x, it means you're taking the f function, the first one, and you're plugging in the other function. So we're replacing the x that we normally have in f. This x is going to get replaced with the entire g of x function. So our f function, instead of having x plugged into it, is going to have this whole 2x minus 7, this whole g function plugged into it. So where we would have an x normally in this function, where we have the x, instead of having the x, we have this whole thing, this 2x minus 7. I'm going to put that 2x minus 7 in where the x was, and it still has the plus 3, because that's part of the original f function. So you can see this is the f function, right here, this f function, but instead of x, it has 2x minus 7 in that place. So we plugged this whole thing into here, into that location right there. 2x minus 7 went in that spot. So it became like this. Now when you do this, you combine functions, you always want to make sure you simplify. If there's any kind of combining like terms or anything you should do that. So here you can see I have negative 7 plus 3, they're both real numbers, so we can definitely combine those. So for my final answer, I'd make this into 2x minus 4, because negative 7 plus 3 is going to give us 4. And that would be our composed version. So that's the idea. We're combining these two functions to make a single function. Why do we do this? What is going on here? Well, basically, there's a lot of times when you might want to use two formulas back to back. You might take a function or formula and plug a number into it, and then take that value to get out and plug it into the next function. You just do them back to back in a row. Examples might be if you're converting from from Fahrenheit to Celsius to Kelvin, because those are all different temperature, measuring systems. You could do that in a two-step process where you do the first conversion and then the second conversion. And that's what composition does, but what it does is it actually takes those two functions and combines them into a single function that does it all in one step. So instead of having to do two steps, doing two functions independently, you can just use this new combined function and it does the whole thing all in one step. So that's the idea. We're kind of combining functions into making one function that does both steps. And it does it in the order where it does the inside function first, so it does the g function first, and then it does the f function. And that's the way the order is combining. So the order does matter here. If you do f of g of x, that's different than if you do g of f of x. So if I want to do g of f of x, g of f of x is backwards now. So instead of plugging g into f, this one is taking the g function and plugging in the f function. This always kind of felt backwards to me, and this makes more sense to me where I can see how f is what's getting plugged in, and g is the function that I'm plugging it into, because you can see this f of x going inside of this g function. The letter order is the same, but I like this notation or way of writing it, because I can see that the f of x is what's getting plugged in. I can see that this thing, f of x, is now going in for x, and this thing. That's what's happening. So it's going the other way. So f of x, we said, is that square root of x plus 3. So this is taking the g function and plugging in square root of x plus 3. That's what this is doing. And since the g function is 2x minus 7, when we do that, we replace the x after the 2 with this root. So we get the root x plus 3 after the 2, and then this minus 7 still out there. This one, there's not really any simplifying you can do. You can't multiply a number through a root. It doesn't work. This minus is outside the root, so it can't subtract it with the 3 because the 3 is inside the root. So this one is just done like that. That's all you can do with that. Again, g of f of x means take the f function, which is the root, and plug it into the g function, which was the other one. So we plug this root into the g function. So replace the x that was here, so 2x minus 7, with that whole root. You just got to be careful about the order, f of g versus g of f. The order matters. You can see we've got two different answers, two very different answers, depending on which order we did. That's the main idea from this section. So this section is all about these compositions. That's what we're going to really talk about this whole section. Now, when you combine these functions with composition, you can still talk about domain. Remember, we said domain is the values that you're allowed to use. These will be values for x that work. Remember, the only things we always watch out for is when we're working with domain, we have to avoid fractions with 0 on the bottom, and then square roots of negatives. So that's what we're always going to be worried about. So that's what's going to cause problems. So we're always going to look for that. So if you see fractions, you see square roots, then you're going to be worried about, okay, I don't want to square root a negative, I don't want to divide by 0. And that's what we're going to watch out for. So we're talking about domain, we're kind of looking for those things and trying to avoid that. Okay, so the domain of a composition, so domain of f of g of x, has all the values that are in the domain of the inside function, which is the g function. That's the one you do first. And also have an output from g, so the result that g gives, it is on the domain of f. Because like I said, when we do these, we're actually doing two functions. We're doing, our value x is going into the g function and giving g of x, the result. And then that value is going to go into the f function and give our final result, which is going to be f of that g of x. So we're going to use the g function first to get a result and then use the f function. So the first number we use has to be able to go into g. Because if it can't go into g, then we can't use it. And then once we get a result from g, that value has to be able to go into f. Because if it can't go into f, we can't use it. So we have to worry about those two things happening. So if x is in the domain of your combined function, then g of x exists. So when you do g of that value, you get a real number. You get something that works. And g of x, when you get the result, that has to be in the domain of f. So that whole thing has to be true. If that's not true, then x is not in your domain. So we have to look at both the g of x, so we have to say that the first function will work on that x, and then the result, g of x, is in the domain of f. So the result is going to f. Okay, let's try this example. We're going to look at these two functions, f of x, which is 2 over x minus 1, and g of x, which is 5 over x. So we're going to determine the domain of f of g of x. But we're not going to actually combine them yet. We're not going to do that to figure it out. We're going to actually just look at these two functions and figure out the domain. Now, first off, before we do anything else, let's talk about the domain of these two functions. So first off, the domain of this guy, 2 over x minus 1, well, the only thing we have to worry about here, because we have a fraction, is dividing by 0. So we always have to worry about fractions over 0. And the only way I'm going to make the bottom 0 here is if the x is a 1, right? Because 1 minus 1 is 0. I don't care if it's 0, because 0 minus 1, that's negative 1. That's okay. I'm only worried about getting 0 on the bottom. So for this one, x can't be 1. So my domain for this function is going to be everything besides 1. So the domain for this guy is going to be negative infinity to 1 union 1 to infinity. Remember, that's how we write the domain, where we just cut out the 1, because that's the only thing we don't want, is we don't want 1. This next one here, this domain, we're looking at this fraction. Again, we don't want the bottom to be 0. In this case, the only problem I'm going to have is if x itself is 0. So we don't want x to be 0. So in this case, we don't want x to be 0, because 5 divided by 0 is the only problem. We don't want 0 on the bottom. So the domain for this one, the domain for g, is from negative infinity to 0, union 0 to infinity. That's the domain for that one. Okay, so that's the domain for the second one. So now, for a function, for this combined function, f of g of x, for something to work in that, to be in the domain of this guy, since I'm doing f of g of x, first my values have to be numbers that I can use with g. So first off, with the g function, I'm not allowed to use 0. So g of 0 does not exist. So 0, 0 equals x, not allowed. I always have to look at the first thing as the inside thing. Can't do this, so if I plug a 0 in, it doesn't work. The second part now, is I'm going to look at the outside function f. And we said that we don't want to do f of 1, because f of 1 does not exist, right? We don't get a result. If you put 1 in there, 1 minus 1 is 0, this doesn't work. But to get a 1 here, that means that g of x would have to be 1. Well, what would x be if g of x is 1? So what's going to make this equal to 1? Well, g of x is 1 if x is 5, right? Because g of 5 would be 5 over 5. And that would equal a 1. So even though this is okay, you can do g of 5 and you get a 1, that's okay. Once you get that 1, the next step is going to be to plug it into f, and f of 1 doesn't exist. So even though 5 doesn't seem like it should be an issue when you're doing the first step, when you go to the second step and you say, oh, but I can't plug 1 in, 5 gives you a 1 to plug in, and that's not allowed. We don't want a 1 to plug in. So that means that this, x equals 5, is not allowed. So these two numbers, x equals 0 and x equals 5, those are our problems. Those are the numbers that are going to give us issues. So my domain for this function, domain of f of g of x, so the combined function, is going to be everything except for 5 and 0. Those are going to be the things I take out. So I'm going to go from negative infinity to 0. You're going to jump over 0, go from 0 till I hit 5. You're going to go from 5 to infinity, and that is going to be my domain, because it took out both the 0 and the 5. Both of those things were bad. We don't want either of those. Okay, now that was without even finding the combined function. We never combined these, and we still could figure out the domain. But what happens if we want to try and combine those? What would the function look like? So let's do that. And you saw last time that sometimes you could look at the combined function and kind of figure out the domain there. So let's try that. So we're going to find the combined function. So using these two functions, f and g, f of g of x, remember that that takes the f function and plugs in the g function. We're going to plug g in, which g we said is 5 over x. So this is doing f and plugging in 5 over x. And that would give us, well, since f is this 2 over x minus 1, we have 2 over, but instead of x, now we have 5 over x minus 1. So that's the combined function. Now this has got that fractions inside of fractions thing, which we don't like. So we always like to try and simplify this a little bit. And the trick here to get this one simplified is actually to do a little multiplication trick. We can actually multiply the top and the bottom of this fraction by the denominator of this inner fraction. So anytime you have a fraction inside of a fraction, you can get rid of it if you multiply by that same denominator. Because multiplying by x will cancel this division. Well, you can do that only to a fraction if you do it to both the top and the bottom. We know the rule of fractions, right? You can't multiply just the bottom, you have to multiply both top and bottom. And that will actually fix it, because on the top we'll just get 2 times x, which is 2x, that's easy. On the bottom, this x goes to the whole thing, so it goes to this whole thing. So x times the 5 over x, well, the x's cancel, so we're just left with 5. And x times 1 is x, so we just end up with 5 minus x on the bottom. So that's the combined function. This is the composed function. This is f of g of x. But when you look at domain and you look at this, you'll notice the only thing that tells us about domain right here is that x can't be 5, right? Because if I put a 5 here, 5 minus 5 would be 0, and that would be bad. We don't want 5 minus 5 equals 0. And we know that we really want to have both 5 and 0 be issues, because that's what we said earlier. We said, oh, these both are issues. You don't see that here. But you do see the 0 be an issue if you look previously. If you look up here, you'll notice right here that x can't be 0, because if you make x 0 here, then you're dividing by 0 before you ever multiply. You can't divide by 0 ever, so that's actually not allowed as well. So actually both numbers are still not allowed, so our domain actually does end up being the same thing. It still ends up being that the domain is everything but 0 and 5. We don't want 0 or 5, so it's still negative infinity to 0 union 0 to 5 union 5 to infinity. So that's still our domain. And that's the one problem with doing the composition first. And like, I actually kind of like to do the composition first. I think it most of the time works pretty well. The problem is you might miss one of the things you have to take out. Now, if you're really careful and you watch as you go, as you simplify, you look for every time an x is on the bottom and watch it for that and find those like restrictions, those numbers you can't use. Then you can always catch them all, and that will work for you. But you have to watch carefully, make sure you don't miss them. Because if you just look at the final result, you won't see all the restrictions. You'll just see some of the restrictions sometimes. So that's composition. Again, with domain of composition, you can figure out the domain without figuring out the composition, because you just have to think about the first function, the inside function, what doesn't work there. That's part of what you remove. And then the second function, what do we not want in the second function? And what from the first function would give us that? In this case, 5 gave us the 1, right? 5 gives us that 1 we didn't want. That's why we took out the 5. Okay, let's look at evaluating these compound functions. So we can evaluate these just like we did the last section where we had the addition, subtraction, multiplication, division. We evaluate those functions that we plugged in. And just like that section, we actually have two different ways we can do this. First, we can compose the functions, put them together and then evaluate. Or we can actually evaluate them first and then compose them. So we can do it either way. And I'll show you both again, just like I did last section. So I'm going to start off and I'm going to compose the functions and then plug in the values. I'm going to first compose the functions and then plug in the value. I think that highlighter is a little too dark. I need to put it off to the side so we can quit pulling it out. So we're going to compose first, and then we're going to plug in the value. That's what we're going to do the first time. So this one wants us to find f of g of -1. So -1 is going to be plugged in. We're going to do that later. So first off, we're just going to find out what f of g of x is. So here we're composing first. So to compose these, that means I'm taking f of g of x, right? So I'm doing f of g, so I'm going to do g is going inside. So I'm taking the f function and plugging in g function. In this case, g function is that 4x plus 3, so I'm plugging in that 4x plus 3 into my f function, which is this thing. So I'm getting f function, which is this thing, and I'm replacing all the x's here with 4x plus 3. So I have 2 times, instead of x, I'm going to have 4x plus 3 squared plus x, but instead of x, I'm going to have 4x plus 3 and then minus 9. Now that's not very simplified, so I should probably go ahead and simplify this a little bit. So let's make this a little nicer. So I'm going to simplify. So first off, I can see things like this squaring needs to happen. Remember that when you square parentheses like this, what you end up actually doing is you actually take that 4x plus 3 and multiply it times itself, 4x plus 3, using a FOIL. So I would FOIL this out. 4x times 4x is 16x squared. And then I do outside 4x times 3 is 12x. I do my inside 3 times 4x is 12x. And I do my last 3 times 3 gives me 9. These middle two terms do combine, so I can get 24x in the middle, plus 9 and plus 16x squared. And that would be my combined thing. Okay, so that's simplifying that a little bit. So I replace that, and I've got 16x squared plus 24x plus 9. Over here you can combine the 3 and the -9, so you have plus 4x, and then 3 minus 9 is -6. And go a little bit further, I can distribute to get rid of this parentheses, just make things a little bit simpler. So I got 32x squared plus 48x plus 18, still plus 4x, and still minus 6. Last thing, I'm going to go ahead and combine some more like terms. So I get this 32x squared just stays the same. 48 plus 4 gives me 52x. 18 minus 6 gives me plus 12. And there we go. We've got the simplified combined function. There it is. What we do with that now is now we can plug in the -1. So let's take this thing and plug in -1. So f of g -1, well, we're going to plug in that -1. So we have 32 times -1 squared plus 52 times -1 plus 12. Well, -1 squared is just 1, so that just becomes 32, because 32 times 1 is just 32. 52 times -1 becomes a minus 52, plus 12. 32 minus 52 is a -20, so a -20 plus 12. And that gives us a -8. And that's our answer. So we get -8 for that part. And that's probably the long way to do it. This works. You can definitely do this. You can can compose them first and then combine them. But there are a lot of times where it's actually easier to maybe do it the other way. So instead of, combining them first, we can really evaluate each function one at a time. Now, the big difference here is when we do this, we do not want to plug -1 into both functions. So this is the big difference here, because we're not plugging -1 into both functions and then adding them or subtracting them. What we're doing is we're actually finding f of g of -1, which means we're taking f of g of -1. So we're plugging the -1 into the g function and getting a result, and then the result is going to go into the f function. So we're going to do g of -1 and then f of the result, whatever the answer is when you do g of -1. Because you're plugging the -1 into the g function first and getting a result, and then that result is going to go into the f function. So we're going to do it in 2 steps. So first off, let's find g of -1. What is g of -1? So we're plugging -1 into this 4x plus 3. So we get 4 times -1 plus 3. Well, 4 times -1 is -4 plus 3. That gives us -1. That was a bad example. I really need to fix that example. You usually don't get the same answer out as you plug in, but I picked one where you did. So this is like the worst example ever, and I thought I fixed that in my notes, but I guess I forgot to. So notice that this is not the same -1 we started with, which is a silly thing to say, but this is the result from doing g of -1. And I really want to point that out because we're not always going to plug the same number in. In this case, we're plugging this result. This is going to go into f. So when we do f, we're taking the answer we got from g of -1 and plugging it into f and then doing f. So most of the time when you do this, if you're not unlucky and pick a bad example and always forget to change it in your notes, when you do this, the number you plug in the first time will be different than the second time. So this is usually different. Not always. Here's your example where it's not different, but usually you pick a good example and the numbers are different. I thought I fixed this, but I guess I forgot to. So you get to deal with having that mistake in my notes. Okay. I'm doing the problem right. It's just not coming out the way I wanted it to. Okay, so we're going to plug -1 now into the second function here. So this f function, it's going to get the -1. So we're going to plug that in. So we have 2 times -1 squared plus -1 minus 9. Well, -1 squared is 1, so we get 2 times 1 is 2. Plus the -1 minus 9. 2 plus the -1 is 1. Minus 9 gives us -8. So the answer is -8, just as we got the first time. You can see the work we did this time was much shorter than the work we had to do up here. Now, why would you ever do this? Well, you might do this if you needed to combine the functions and then plug in a bunch of numbers, right? So if any time where you say, okay, I have 5, 10, 20 numbers I'm going to plug in, so you're not just doing f of g of -1, but you're doing f of g of -2, -3, -4, -5, a whole bunch of numbers, then this would make sense to do. Find the composition and then just do this part over and over again. But otherwise, if you're only going to plug in one number one time, then you probably just want to do it this way. And that's going to be the easier way to do it. Just, plug it into the inside function first, get a result, and then plug that result into the other function. Okay, last page. I'm going to pass that hurdle. Using graphs. Now you can use graphs to do kind of the same thing. We talked about graphs and evaluating graphs already. We can evaluate graphs. So if I want to do like f of g of 3, then what I'm going to do is I'm going to find f of g of -3. So I'm going to actually find g of -3 first. I'm going to figure out what is g of -3. Remember that when you do this, you're saying this value is going in for x. So you go on your x line and you find -3, which is right here, -3. And then find the g function, which is this one down here. So you get the value, which is -1. So the g function will give us -1. And so then that's going to replace this g of -3. So g of -3 we found out is -1. So we're going to turn this into f of -1 because we found the result for the g function, and then we plug that result in for the f function. So for the f function, we're going to go over to -1, which is right here, -1. And f function, the value for an f function right there is 8. So this guy gives us 8. So we did -3 into the g function, got -1 for an answer, did -1 into the f function, and got our final answer. Let's try it again. Let's try a different number. So let's do g of f. So we're doing backwards now. We're going to do g of f of 3. So we're going to start off by doing f of 3. That's my first step. So I'm going to go over to 3. And do my f, which is this guy here. So I get 4. So f of 3 gives me 4. And then from 4, I'm going to go to my g of 4, because we found out f of 3 is 4. And I'm going to plug that in and go to my f function. So that goes up here, and I get, oh, whoops, this is f. I already did f. I'm doing g. My bad. Ignore that. Going down. G. G is going to give me negative 8. So g of 4 gives me negative 8. So again, you're not plugging the same number in both times. I'm not doing 3 and 3. I'm doing 3, getting a 4, and then I'm plugging in my 4 and getting my final answer. So that's the difference. When you do composition, you're just plugging the same number in twice. I'm not going to plug 3 into both functions and get both results. I'm plugging 3 into the inside function first. I get an answer, and then I plug that answer into the other function. Okay, last little set of notes right here, last little part of this notes. Just something kind of fun and interesting that's in the homework. I just want to make sure it helps you out with a little bit. So in this part, we're going to decompose a function. So we're actually going to take a function that was composed and break it apart into two separate functions. So sometimes it's helpful to express a function as two separate functions being composed. So we're going to think of this function h of x as the composition of f of g. We want to think about what f of x and g of x could be to make this composition. And there's not just one right answer. There's a couple different right answers to this. A few different ways to do it. One example was you could say that f of x would be 1 over x to the 5th. So if you make f of x 1 over x to the 5th, and then you're doing f of g of x, remember f of g of x is f of g of x, means you're plugging in g into f. And the g function would have to go in there for x and change this to look like this. Well, what would g have to be then? G would have to be the x minus 5. So g would be x minus 5. Because when I take this function and plug it in, so if I do f of g of x like this, I would take this and plug it in for x, then it would look like this. So that's one way to do it. I'll show you one more way. What if I did f of x, and this time I just made f of x 1 over x. So f of x is 1 over x. That's it. It's just 1 over x. Well then g of x would have to be something that when I plug it in there for x, it makes it look like this. So g of x is going to be x minus 5, the quantity, to the 5th power. Because if I take this whole thing and plug it down in there for x, then I'll have 1 over x minus 5 to the 5th power. So that works. So there's actually always more than one way typically to decompose, but you got to make sure that when you compose them again, so when you go back to put it back together, if you plug that g back in where the f is, and where the x is in f, then it would look like your original composed function. So we're trying to write these two functions, and there's a couple different ways to do it, that they would compose to give you that result. Okay, that's it for composition. Composition is fairly important. We are going to see this come up throughout the rest of the semester. So you really need to get this idea of if I take one function and plug it in the other function. It is an important concept. It's something that we'll see come up throughout the rest of the semester. So I want to make sure that you're, do this homework set, ask any questions you have. Make sure you use that Ask My Instructor button if you get stuck on anything. This is a section we'll definitely come back to as we go through the rest of the homework for the rest of this semester. So thank you much, and I'll see you on the next set.